Welcome everyone, we're doing the Mathematics Content Knowledge Asvab prep test. We are doing 2 questions per video. There's gonna be 15 videos for this section. There's also gonna be 15 videos that you will see that is part of the arithmetic practice test. And so we're gonna get you ready to go with that Asvab. And we're gonna get started with this first question, which is this triangle up here, right triangle. And we're asked that if the area of the triangle is 6, what is the perimeter? And we're only given one piece of information, which is that is a 3. So we are going to have to use the Pythagorean theorem in order to do this. So what we're going to do is we're going to start off with the area of a triangle in order to figure this out. So we'll start off with the formula of that. So we will start off with the area is equal to base times height divided by 2. And we do know the height. The height is the vertical. That is this piece right here. So that is 3. So I'm just going to take the h and I'm going to replace it with a 3. So what you're going to have is 3 times b. We're going to find what the b is in a minute. And we're going to get rid of that, the 3 and the 2 around it. So the first thing you want to do is when you have numbers in a fraction surrounding a variable, you do want to just do the reciprocal. So you multiply it by its reciprocal, or its flipped over version, 2 over 3. So instead of 3 over 2, you multiply it by 2 over 3, because what that's going to do is it's going to cancel. There's a 2 in the numerator, a 2 in the denominator. Those will cross simplify. The 3 in the numerator, the 3 in the denominator will also cross simplify, leaving you just with that b value. Now we did that to that, and we already know that the a is 6. So we're going to multiply this by 2/3 as well. Now, you can do this a couple of different ways. I'm putting the 6 over 1. That way it keeps it consistent, fraction times a fraction. And then I can simplify it a little bit more with the cross simplification. 3 goes into itself once. 3 goes into its 6 twice. And so you do 2 times 2, which is going to be 4. And obviously 1 times 1 is just going to be 1. So that means that 4 is my base. So we have those 2 pieces. Now we have 2 of the 3 pieces in order to figure out our perimeter. So the only other thing I would need to do at this point is to take a look at using the Pythagorean theorem to find out that last piece. Now, if you are familiar with the Pythagorean theorem and you look at these numbers, you should be able to identify what kind of a triangle this is. But if you do not know a Pythagorean triple, which is 3, 4, and 5, then what we're going to do is we're going to check out using Pythagorean, which is a squared plus b squared equals c squared. And we have our a and our b. Our a is the smallest side, so whoops. So we have 3 squared. And our b, which is the second longest side, those are the 2 legs. So the legs are always the 2 pieces that form the right angle. And then we're going to do c squared. And so our 3 squared will be 3 times 3, which is going to be 9. Our 4 squared is 4 times 4, which is 16, and that equals c squared. Add these 2 together, you get 25, which is equal to c squared. And in order to get c by itself, we need to do the opposite operation of squaring, which is the square root. We square root both sides. The c is now by itself like it needs to be, and the square root of 25, hopefully you know, is 5. So that means that that 5 is confirmed, that is the final piece. And then when you add all those together, the perimeter will be 3 plus 4 plus 5. And so when you do that, you get 12, which means your answer is B. So that is that question. So B would be your question answer for that one. Now let's go ahead and take a look at this next one, which is a little bit trickier. If the perimeter of an equilateral triangle is 24 centimeters, then what is its area? Okay, so again, we do need to do a little bit of Pythagorean theorem here. So what I am going to do is draw a triangle, which is an equilateral. Again, equilaterals are all sides equal. So you have an 8 by 8 by 8, which means obviously that the perimeter is adding up to 24. So what we need to do is figure out a couple of additional pieces. We need to find out what the height of this triangle is. In order to find out what the area of that triangle is, we are going to have to find out that vertical height. So the vertical height is always from the tippity top of the triangle to the very bottom of that triangle, because that's the highest point. Everywhere else is that 8 would be considered a slant height. So in order for me to do that, because this is an equilateral and you're splitting this half and half, this side and this side would have to be the same size. So that means this is 4 and this is 4. So what I'm gonna do is just kind of redraw that. This is 4 and 4. So now you have a right triangle here. I'm just gonna move this over so you can see it a little bit better. So you have a right triangle with an 8, a 4, and a missing side here. So again, we're gonna use the same volume, same area, or same formula, can't even think, that I used a few minutes ago with the a squared plus b squared equals c squared. And this time I have the c squared because I have the hypotenuse. So the 8 is your c squared. Hypotenuse is always directly across from the right angle, which is right there. And then the 4 doesn't really matter. It is, you know, whatever. It's the a squared. It doesn't matter if it's the a squared or the b squared. I usually just put it in as the a squared. Whatever piece is the leg that you're missing, I usually just throw it in because it's easier there. It doesn't really make a difference. You square that, you get 16. And then we're going to get, obviously, b squared here. And 8 squared is 8 times 8, which is 64. Now that I've done that, now what I'm going to do is the opposite of what I did last time. So now I want to get b by itself. So I need to move this 16 over. So when I do that, that's going to cancel me out. And then we're going to be left here. We're going to end up with b squared on this side. And then over here, we have to do our 64 minus 16. So again, anytime you have the hypotenuse and a leg, you are going to have to subtract the leg from the hypotenuse answer. This isn't going to come out nice, so it's going to come out a little bit weird. So we have to do the opposite operation, which is square rooting the square. And here's where you need to know your perfect squares. So b is going to be equal to, you're looking for perfect squares that go into 48. And the only one that I'm thinking of, the highest one, you always want to try to use the highest one to go into it. Highest one that goes into it is 16. So kind of when you're doing these, you're looking for an extraction of a square root. So if you don't know how to do that, I do have some videos on how to do that. But 16 square root times the square root of 3 will give you 48. 16 times 3 gives you 48. But this is a perfect square, which is 4. So your height is 4 root 3. So that is what your b is. Now, we're not done yet. So we've got that. We've got the 4 root 3 as the height. So now I'm going to go back up here to this triangle. So here, 4 root 3 is this. But really, not only is it there, obviously it's up here too. So this is the whole triangle. This is only half of it down here. So this is a part of it. This is the actual full size we started with. So what I'm going to kind of do is just make that a little bit bigger, clean it back up with the stuff that you need in it. So here's your triangle. Again, pretend like this is a legit drawing and this is all equal sides. So this is 8, 8, and 8. Our height we just figured out right here is 4 root 3. This is a lot of work to do for this problem, but it's worth it. Then what we're going to do is base times height divided by 2. So our base on this is 8. That's the bottom. Our height is that 4 root 3. So you're going to do 8 times, 4 root 3. And then you're going to divide it by 2. So that's base times height divided by 2. So you're going to get 32 because you can do 8 times 4. Now the square root of 3 is going to stay square root of 3. So you're going to have 32 root 3 divided by 2. And then you can divide the 32 divided by 2 part. You can't do anything with the root of 3. But 32 divided by 2, you'll get 16. 16 root 3 is your area. And when you look back up at the choices that we have, as you can see, that is choice D. And if you want more questions like this, find them on my YouTube, Instagram, and TikTok at YouWantAlgebra. All these are going to be located in the Asvab portion of my playlist. If you want more stuff with the Pythagorean theorem, that can be done in the Pythagorean theorem playlist. If you need more help with the areas and perimeters, I have an area and perimeter playlist as well. If you're looking for how to square root, do all that stuff with the extracting square roots, there is a square root playlist as well. And don't forget, like, share, and follow me for more.